Average waiting time. So we are given an input of each customers and their arrival time, and whatever food they have ordered, the time that food will take to get prepared. And we have only one chef and he will do the cooking one at a time. So we have to calculate the average waiting time for all the customers, right? Let's try to visualize it with an example. Assume we went to a restaurant, right? We went to a restaurant. We have ordered some food, right? We ordered some food, and the food will take, like, let's say 2 minutes to cook. So there could be two possibilities, right? I'll have to wait 2 minutes. If chef is free, he'll start cooking my food, right? If chef is free, he'll start cooking my food. And if he's busy, so for how long he is going to be busy? That we need to know. So how can we know that if the chef is busy? What if he's already cooking for someone and he started at, like, let's say 10, and he's cooking something that will take 4 unit of time. So he'll be cooking till 14, and I have reached somewhere in between, like I have arrived at 11. So he's cooking till 14, right? So I have to wait additional 3 unit plus whatever time my food is going to take. So 3 plus 2. So I'll have to wait 5. So this is the intuition, right? If we have arrived to a restaurant and the chef is free, then he'll start cooking and I'll have to wait only the time that the food is going to take. If he's busy, which we can identify by taking the consideration of the time, what he was cooking previously, at what time he'll be cooking, and from that time, if we subtract our arriving time, we get the extra time we have to wait, which we got in 3. If we take the example that is given in the question, like 5 2, 5 4, 10 3, and finally 21, right? So we 2 customers arrived at 5 5. Okay, since it's in the ascending order, the chef will start cooking for the first one. So he'll start cooking, right? 6 7. So he'll cook for the 2 unit of time. So the current time of the chef will be like 7. Till 7 he is cooking, he is occupied. And waiting, right, because the chef was already free, so the waiting time will just add the food time to it, right? So waiting will be how much? The first customer has to wait only this much time, 2. Perfect. Now the second, for the second customer, how long he has to wait? He has arrived at 5, right? His cooking will start at 7 and it will go 8 9 10 and 11. Then his cooking will go in this time bracket. So how much? This much time we already know, because his food is going to take 4 unit of time. But this time he has to wait additional time, right? Additional time he has to wait. So what is this time? This time is nothing but the previous current time of the chef, current time minus his arrival time, right? So in which scenario we can say that he is free, or if it's not free, we can simply check, right? If the current time, if it's greater than or equals to, let's say, the arriving time, then in this scenario he is already busy, right? So in this time our waiting time will be a bit different. In the waiting time, first we'll add the difference, right? The current time difference minus the arriving time difference, and then we'll add the food time to it. Perfect. Then we'll add food time to it. So that's how we'll get the waiting time updated each time. So next time he has to wait this much 2 plus his food, so 6. So we'll add 6 to our waiting time, right? This we got by the difference of the current time and this time. And at the same time, now the current time also needs to be updated, since he was busy, and the moment he finished, he'll start cooking for the customer. So current time plus the food time, that much time again he is like busy for. So the current time we'll add just food time. Okay, now the third one, he has again arrived at, previously he was already busy, so he has to wait additional 1 minute, and 3 for the 12 13 14 for the food to be ready. So he has to wait 4. So we'll add 4 to our waiting time. Again, it will go into this if condition only, right? Because current time is greater, was greater, it was 11, it was 10. So waiting time will just add it and current time will update it. But let's say for the last one, right? Let's say for the last one, he arrived at 20. My chef was occupied at till like our current time was 14, right? He was only occupied till 14 and he is arriving at 20. So our chef is free. It won't go into this if condition. It will go into else section, right? So for him, how much time does he has to wait? Because the chef is already free. So he'll start cooking his food immediately. So he only has to wait only the food time, right? So waiting time, in the waiting time, what will add? We'll just add the food time. But now we have to see carefully, like what will be our current time, right? So current time will be now his arriving time, the customer arriving time, plus his food time, right? That will become his current time. Till that time, this chef is going to be busy. So what we'll do? Arriving time plus food time, right? This will tell us the current time, like this much for this time. The current our chef is going to be busy, and once this is done, like we have iterated over all the input, we'll just return waiting time. Actually, waiting time is storing the all wait total time waiting time. So we have to, since we need the average, we have to divide it by the customer's number. So customers size, and this will give out the answer. Let's move to the coding, so we'll see it better. The answer we need to return in double, so we'll take double. Waiting time is 0, and starting time we need, right? So int starting time, or let's say current time, is the first customer's arrival time, right? So 0 0, and if you see the condition, there will be a one customer at least, right? So that's fine. For n, we'll start iterating on the input. For each customer, we'll take their input time and the food arrival time. So int arrival time is this, and int food time. Right, we got this. Now we have to check if the chef is already occupied. So current time, if it's greater than equals to arrival time, so we have to wait extra because we arrived early and already busy, right? So waiting time will be the difference. This much time we have to wait extra, right? So current time minus arrival time. Then we have to wait for the additional food time, right? This was the additional time we have to wait, and this much time we have to wait for our food to get prepared. So this will be the total waiting time that will add to the final result. And current time, right? So what will the current time? Current time will be, we'll just add the food time to it. Else we are already free, so waiting time will be, we'll just add the food time to it. And current time, right? Since I started cooking at this time, and plus the food time, this much time. For this time he'll now busy. And if we return waiting time by total number of customers, it should be fine. Let's submit it. Yeah, it's done. One more thing, like it's not important to have equal to, because anyway it's going to be the same, right? Because both are almost the same, because this will be 0, current time and arrival time, because they are same. So it becomes 0. So food time, waiting time equals to plus food time is this only. So even if I think we remove this part, right, and try to run it, it should run perfect, right? Because then it becomes as this condition. So ultimately both were acting in the same fashion.